Students, welcome again. As far as this online lecture series is concerned, we are continuing this topic, that's carbon and its compounds. Let's take this carbon more forward. The last time we were talking about, let me recapitulate certain things regarding this carbon. Last time we were talking about that carbon always form bonds by sharing of electrons. By sharing of electrons, and those particular bonds are called as covalent bonds. We have discussed this very thing in the last video lecture. Let me add one more thing to this. As far as this carbon is concerned, carbon is having atomic number of 6. That means in first shell, in K shell, it contains 2 electrons, and in L shell, it contains 4 electrons. Now, one more possibility is here, that this carbon, I told you people yesterday that in its first shell it contains 2 electrons, in its second shell it contains 4 electrons. But last time we discussed that it's not possible for the carbon either to gain electrons or either to lose as many as 4 electrons from its valence shell because of the energy considerations, and we have discussed this very thing. And next thing I would like to add here, that as far as this carbon is concerned, it's having only 2 shells. That's shell number 1 and shell number 2. One is K shell and another is L shell. At the moment it's having only 2 shells. These negatively charged electrons, because as far as this electrons is concerned, they are having charge of minus 1.6 into 10 raised to power minus 19 coulomb. And as far as this nucleus of carbon is concerned, nucleus is having positive charge containing protons plus neutrons. And as far as these protons are concerned, they have a charge of plus 1.6 into 10 raised to power minus 19 coulomb. And collectively, protons and neutrons are called as nucleons. So, I can say the moment I am telling you that as far as this carbon is concerned, it's having only 2 shells, and it's not possible for the carbon to lose these 4 electrons or either to gain as many as these 4 electrons because of the energy concentrations. Now, one more thing, as far as this carbon is concerned, carbon is having only 2 shells. At the moment it's having 2 shells, this carbon is having 2 shells. That means these negatively charged electrons are tightly bound to the nucleus. They are tightly bound to the nucleus because there is always positive negative attraction. Positive negative attraction between positively charged protons and negatively charged electrons. So this carbon is not in a state to lose 4 electrons or to gain 4 more electrons because of the energy concentration. And one more thing is that this nucleus does not allow these carbon 4 electrons to lose because these 4 electrons are tightly bound to the nucleus. The moment they are tightly bound to the nucleus, it is that impossible for we people to remove these 4 electrons from the valence shell of the carbon, because this carbon, the nucleus of the carbon, is always in a case, always in a state, always in a search to attract these 4 electrons towards itself, because these electrons are having negative charge and these protons are having positive charge, and there is always positive negative attraction between these positively charged protons and negatively charged electrons. So I think you people have got this. Now let's take this forward. Now we have one more topic, that's covalency. That's covalency. A covalency, it's actually number of electrons is shared by an atom shared by an atom with other atoms. They may be same atoms as well, same, or with other molecules to form covalent or chemical bonds. A covalency, as far as this covalency is concerned, covalency is actually the number of electrons shared by a particular atom with other atoms, and these atoms may be same as well with other molecules to form covalent or chemical bonds. Let me give you an example of this. This is carbon, and in case of methane, we discussed this very thing in the last lecture. As far as carbon is concerned, carbon is having atomic number of 6. That means in first shell it contains 2 electrons, and in second shell it contains 4 electrons. That means it's having 4 electrons in its valence shell. This is 1 electron, this is second electron, this is third electron, and this is fourth electron. Now we have 4 hydrogens. It's 1 hydrogen, is second hydrogen, this is third hydrogen, and this is fourth hydrogen. And as far as this hydrogen is concerned, hydrogen is having atomic number of 1. Atomic number of 1 means its valence shell also contains 1 electron. 1 electron. That means this hydrogen is having 1 electron in its valence shell. This is having 1 electron in its valence shell, and this hydrogen is having 1 electron in its valence shell, and this hydrogen is having 1 electron in its valence shell. That means this carbon will share 1 electron and this hydrogen will share 1 electron, and there will be a formation of a bond that's called as a covalent bond. Covalent bond. And this will form another covalent bond, and this will form another covalent bond. This will form another covalent bond. Now the question arises that every single thing in this universe tends to be stable. Now look, this carbon attains the nearest noble gas configuration by sharing its 4 valence electrons, 1 with this hydrogen, 1 with this hydrogen, 1 with this hydrogen, 1 with this hydrogen, thereby stabilizing this hydrogen as well, like this, like this, like this, like this, and also it gets stable, and carbon itself gets stable like this. 1, 2, 3, 4, 5, 6, 7, 8. That means it achieves the nearest noble gas configuration. And that means by sharing of its 4 electrons with other hydrogen atoms, carbon gets stable. And it's actually the number of these, I can say, shared electrons. Number of these shared electrons defines the covalency of an atom. So covalency is directly proportional to the number of shared electrons. This carbon shares 4 electrons with other hydrogen atoms, and the covalency of the carbon is 4 because it shares 4 of its electrons with the hydrogen, thereby stabilizing the hydrogen and thereby stabilizing itself as well. Now the question arises, how many electron pairs are? That means these are actually 4 pairs, 4 pairs of electrons. And here the covalency of the carbon is 4. 1, 2, 3, 4, because it shares 4 of its valence electrons with other hydrogen atoms. Let me make you more clear by giving more examples. This is hydrogen, and this is another hydrogen in case of H2 molecule. As far as hydrogen is concerned, it's having atomic number of 1, means it's having 1 electron, valence electron, and this hydrogen is having 1 electron in its valence shell, and there will be the mutual sharing between these 2 hydrogens, thereby forming a chemical bond, and this bond is also called as covalent bond. Here the covalency of the hydrogen is 1 because it shares 1 electron with other hydrogen. Now another example in case of oxygen, O2 molecule, the atomic number of atomic number of oxygen is 8. That means in first shell it contains 2 electrons. In second shell it contains 6 electrons. Like this. This is oxygen. This another oxygen. It contains 6 electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, as far as this oxygen is concerned, this will share this electron with this oxygen, and this electron will get shared with this oxygen. That means as far as this oxygen is concerned, there is sharing of only 2 electrons and sharing of 2 valence electrons by forming 2 chemical bonds. That is, oxygen always form double bond with another oxygen by sharing 2 of its electrons, and these 2 shared electrons defines the covalency of the oxygen. So the covalency of oxygen is 2. Because I told you people that covalency is actually the number of shared electrons with other atom. The atoms may be same. This is same, that's homoatomic. Or it may also heteroatomic as well. Heteroatomic. So covalency of oxygen is 2. Now, covalency of, let's take another example, this nitrogen. In case of N2 molecule, nitrogen is having atomic number of 7. That means in first shell it contains 2 electrons. In second shell it contains 5 electrons, because this nitrogen is in a state to gain 3 more electrons to complete its octet. Because I told you people, the only funda behind gaining or losing electrons is that to achieve stability or to achieve nearest to noble gas configuration. Because noble gases, as far as noble gases are concerned, they are stable at their room temperatures. Now look, as far as this nitrogen is concerned, nitrogen is having atomic number of, I can say, atomic number of 7. In its first shell it contains 2 electrons, and in L shell it contains 5 electrons. This like this, 1, 2, 3, 4, 5. And another hydrogen, 1, 2, 3, 4, 5. And this nitrogen shares actually 3 of its valence electrons with other nitrogen, thereby forming a bond by mutual sharing of electron. This hydrogen provides 1 electron, this nitrogen provides 1 electron, and this nitrogen provides 1 electron. And the bond formed between the mutual sharing is always covalent in nature. I told you people, covalent bond is actually that bond which is formed by mutual sharing of electrons. Now this nitrogen will, I can say, donate 1 more electron to this nitrogen. And there will be the formation of 3 bonds. That's because nitrogen is trivalent in nature. The valency of the nitrogen is 3. Now the nitrogen will form triple bond with another nitrogen, thereby sharing 3 of its valence electrons with other nitrogen atoms. So these 3 shared electrons defines the covalency of the nitrogen. So covalency of the nitrogen is 3. I think you people have got this now. So the covalency of an atom is defined as the number of shared electrons when formed, I can say, covalent bonds. In second definition, rather I will simplify this definition. The covalency is also defined as number of covalent bonds formed, and this is covalency. Thank you for watching this. We will come with another lecture shortly.